Okay, next page. So first up, we have this question here. It's talking about which one gets to the bottom. It's not saying which is going to have the greater velocity. It's saying which one gets to the bottom first. And although they will have the same velocity at the bottom, this one will travel a shorter distance than that. So this will actually reach the bottom first. So it's A. All right, next we have conservation of energy. And we're trying to figure out and fill in the blanks here. The idea is this. The total energy here has to be the same total energy there, there, and there. Okay, so what's our total energy right here? Well, it's 0 plus 100 is 100. So that means everywhere else it has to add up to 100 too. So here is 25 plus 75 is 100. 75 plus 25 is 100. And 100 plus 0 is 100. All right. Now we're going in here and we're looking at something that has a height of 5 meters. And how fast is it traveling at these points? And it's a frictionless surface, so it's just going to keep going through these points all the way around. So for all of those, I'm going to do my work over here. We have at the top, the potential energy there will be equal to, at that point, at B, D, and E, it would be how much kinetic energy. So the loss, we'll say the loss of potential. All right, it goes down 5 meters. So how much potential energy does it lose there will be how much kinetic energy it'll gain here. Don't worry about the triangles right now, but that's how it's changing. The change in potential energy at the top is going to be equal to the change in kinetic energy to the bottom, or to B, D, and E. Okay, so what do we got? mgh is equal to 1/2 mv squared. Again, the masses cancel out, so we have gh is equal to 1/2 v squared, multiply both sides by 2. I went very fast, but I'm canceling out the 1/2, so I multiply both sides by 2. So those cancel out, so I have 2gh is equal to v squared. I square root both sides, and I have that v is equal to the square root of 2 times gravity times height. And I get, I'm going to erase this out of the way. I get the square root of 2 times 9.8, they use 10, that's okay, times my height of 5 meters. And I get that it's going to be, again, 9.8999 meters per second, which is basically 10. All right. So the velocity here is going to be 10. Point D is the same exact height. So all of these are the same. So that's 10. Point E is the same height. So that's 10. Okay? Now, at what point does it have the maximum speed? Well, the maximum speed is going to be down at C, because if it is going more than 5 meters down, it's going to have a bigger change in potential, which means it's going to gain more kinetic at the bottom. We don't have to calculate it because we don't even know what this number is, but it will be faster. So point C has the highest velocity. Okay? All right. Over here, I'm not going to do a full explanation of it, but if you have all these windmills, and it's saying if you're gaining energy from wind, how fast do you think the wind is going behind the windmill? Well, if you're taking energy away from something, it has to be slowing down. If I took energy away from you, you'd end up slowing down too. So think about that, and remember that energy always has to be conserved. So if we're gaining energy in one side, we must be losing it from somewhere else. All right, there you go.